So in this video, we'll see what is a non-deterministic push-down automata. So what is a non-deterministic finite automata? So when you have two different transitions for the same scenario, then that is called as a non-deterministic finite automata. Same way, in the previous example, if you remember, we had a center marker, right? We had a separator, but here we do not have a separator. So previous example was a odd length palindrome. Okay, A B B C B B A. It is not a palindrome. It is just a reverse of a string. So if you have, if both the even after reversing, if both the parts are same, then that is a palindrome. Okay, that is a odd length palindrome. What is the length of this string? It is 7. Okay, including this separator. So this without the separator, it is a even length palindrome. Okay, so first transition is same for both. You push A or B. So that would be what? Q naught is your state. Okay, input is A. Okay, state of the stack is Z naught. Then after adding it is A Z naught. Or your input can be B Z naught, B Z naught. Okay, this is the first state. Okay, then even the second symbol is also fine. So how would here we do not have a center marker, right? So, but how will you know that it has reached the center? In this particular example, consider it as a palindrome. Okay, they are asking you to draw a palindrome, that is even length palindrome. You are going to draw NPDA for even length palindrome. How would you know without the center marker you have reached the center of not or not? So you can identify as end of W. If end of W is equal to start beginning of W power R, then that is a palindrome. Say here you have ABA. So if end of W and beginning of W power R are same, then you can say that it has reached the center, right? Okay, but for in few other examples, see AAA. This is also a palindrome. Okay, this also has same AA in the middle, but in other parts also it has the same elements. So then what you will do? How will you know that there are the end? I mean, the center has reached. So for the same state, there are two possible scenarios for the same input of or what do you say, there are two different scenarios for the same state. Okay, so that those kind of problems are called as non-deterministic push down automata. Okay, so here there are two more states that you need to write. So if the input symbol is okay, next symbol, second symbol. If the input symbol is A and the top of the stack is B, okay, you push it. Okay. Or input symbol is B, top of the stack is B, then you push it again. Okay. So there are two more possible transitions which we saw in the previous example, right? If the input symbol is A and the top of the stack is also A. If the input symbol is B, top of the stack is also B. So this either means there is a center, the center has reached or not. Center or not, right? There are two conditions. So for these two conditions, how would you define the logic? So if it has reached the center, okay, if it has not reached the center, you just add those two transitions here itself. A is the input, top of the stack is A, then you will have AA. B is the input, top of the stack is B, BB is your input. Okay, same as the deterministic push down automata, W power R example. Okay, so what if the center has reached? Okay, you have reached the center. Then what would you do? Okay, you pop. If it is the center, you perform pop operation and change the state. So I will write here. You perform pop operation. So only for these two possibilities you are going to perform pop operation. So your input is A, top of the stack is also A, you pop. or your input is B, top of the stack is B, you perform pop and you change the state. Okay, so now the center, these two are center not reached. These two are center has reached. Okay, for both the combinations you have written. So after reaching the center, you pop all the symbols that you are encountering. Okay, so that would be a self loop. Self loop of whatever you have after that. If your input is A and you have A, pop it. If the input is B, you have B, you pop it. Okay, then what you would have reached the end of the stack, right? Then your last input would be epsilon. Stack would have the initial stack symbol that is that naught, and you pop that also epsilon. So this would be your final state. So this is your non-deterministic push-down automata.